Yeah.
Hello. James.
Hello.
Hi, James.
I don't have any video yet on this. I'll have to put my camera in a second.
Pacific.
Very quiet.
Can you all hear me okay?
Yes. Okay, yes.
Yep.
I believe it's possible to increase the volume somewhere there. Be very quiet.
You want to see the welcome to the data doc?
Yeah, I got some slides. Do you want to promote me?
Oh. Right, need you. Sorry.
All right. Can folks on Zoom hear me?
Yeah, I can hear you.
Yep.
Great.
Can hear you, no problem.
Great. Okay. Hi, everyone. Welcome to Datadog. So if you don't know me, I'm Brian. My name is under yours on your badge right now. Yeah, this is the first event like this of any kind that we've done at Datadog. So this is a bit of an experiment. Hopefully it all goes well. And hopefully you're all customers, right? Everybody's Datadog, right? Yeah. Oh, we got John over there, of course. Okay, probably important, the Wi-Fi. It is Datadog guest. There should not be any password or anything. There might be a captive portal, I'm not sure. But definitely no password or anything. A couple of rules. There's no vaping or smoking inside the building or on these terraces, which we do have access to. We can use these terraces. If you need to smoke or vape, Christy at the back there will direct you to our smoking location, which is outside. There's no food in any of the meeting rooms, please. There have been issues in the past, so we don't allow that here. Drinks are okay. This is an active office, so there are Datadog employees everywhere. We do need to pretty much escort people everywhere. Either Datadog employees or Christy over there can help if you need to get somewhere else in the building. But for the most part, we'll be in here and in the cafeteria downstairs where everybody was just before. We do have the code of conduct from the Linux Foundation, which we're observing here. Joey, I don't know if you want to say more on that one.
Probably just, I'm pretty sure people are familiar with that if you've been to any Node.js events, but if you haven't, check out the code of conduct.
Yeah. Okay. All right, couple of fun facts. There are 2 bathrooms right outside the door. I believe they are single occupancy. There are a few more on this floor, so there should be no issue there. We can use the break area, which is also just outside this door, just directly across. There's coffee and snacks and stuff there. If we run out of anything, if there's no coffee left or something, please let me know. I'll make sure that gets addressed. And again, we do have these 2 terraces to use for whatever we want. We can open these doors if it gets too hot in here, which it often does. This is basically a greenhouse. Yeah. Joy, these are your slides. I don't know if you.
Yes, so lunch break at 12. And then we have t-shirts, you know, where.
Oh, there's a box here.
Maybe I'll find some time during lunch break to distribute that. And we have these there by 6 p.m. But I think we can stay a bit more if we have to, but it's going to get weirder and weirder as the later we stay. And the schedule and Zoom links and no links are in the summary issue. I haven't put that there, but I guess you all know where that is. And the next slide, please. So to participate in the sessions, there's you need to join the Zoom call because we need to be let the remote participants hear us. If you registered through the Google form, you should only have like some email in your mailbox about joining this as a panelist. You need to join as a panelist to speak. Otherwise you can only listen. And well, if you are in the room, you don't need to have that because we have the microphone in the city. So when you join, you need to mute your speaker and your microphone because they're on the city. And I guess when we are actually in the sessions, we'll find a photo or something to make sure that we know who has the floor because we'll need to be in the same queue as people in the remote queue. And we'll just watch the queue and call people to speak in turns. And also, please help us taking notes because I think the last time we tried using anything with AI is not great yet. So, I think that's it.
Yeah, that's all the slides I have. If anybody needs anything with respect to the facility or anything like that, please don't hesitate to ask me either in person or on Slack.
Okay, I guess the first session I have is CI. Well, Matteo proposed to have something about the CI because we don't, despite having a bigger crowd this time, we don't have a lot of sessions, which I guess is also great because we have a lot of informal time. But since we do need to do something, I guess, at least starting from 10, like 10:30. Matteo's suggestion was to do something about CI, or I'm not sure if you noticed that currently the CI is locked. Have we announced the reason yet?
Yeah.
Have you
Yes.
already put out the
On a
Yeah.
blog, yes, yes.
Went out this morning at, I don't know, 5 a.m. or something when I was taking my. It was. Let's start doing a little bit of a recap and then we can get to I start with a recap maybe, and then we can go in details with what Richard has done and so on and so forth. Okay. What happened? I don't know if you are aware, probably a lot of you are. See, I was in lockdown for a week almost. Okay, what happened was that a security researcher was able to found a vulnerability in our CI systems. Sorry.
Can you just tell people if they're looking at the blog now, don't tweet it or post it right now?
Oh, okay.
Okay, you're saying you just said we went public, but while he explains, will you all just not?
Oh, okay, sorry. Well, what I'm going to say here, please keep it semi-confidential, okay? Don't tweet about all these explanation, long form, okay? Please keep it private. We are going to publish a long blog post of all the things that happen and with a timely details and so on and so forth of what you're doing to remedy. So what happened in last on March 21st, a security researcher was able to gain access to our test CI infrastructure, Jenkins. You're all familiar with the friendly Jenkins, okay? By exploiting a time of check, time of use, talk to, as often called, vulnerable check on the request CI or your friendly request CI label. So whenever you attach a request CI label to Kickstart CI, what was happening was that that after a little bit was parsed by Jenkins received the kickstart of that via cron job that scans for all the request CI tags in our issue tracker. What happened is, in order to verify the check that we were doing, in order to verify that was based on the time included in the Git commit SHA. Unfortunately, the attacker found out this, and the researcher, and he was able to essentially do a force push of a commit between the time it was the request CI label was applied and the time it was the thing was actually run.
I would say it's actually not important that it was a force push, though. It was just the time sensitive thing.
Yes,
it's a regular push.
Yes, it could have been just a regular push. It could have just been a regular push with, but with the time altered. Okay, you can, when you create a commit, you can create a commit with the time that you want, and you were relying on the fact that there was actually a valid commit. Anyhow, that is the gist. So the Richard specifically has been very busy doing all the work, okay, on making it alive, restoring CI essentially, and providing a way to run this securely. And I think we are at the point that we can reopen CI. I don't know if Richard has already reopened CI, but I think you can go through what you've done, Richard, maybe.
Yeah. Yeah, I'm I'm just literally back from being off for a few days. So yeah, I think we can unlock the CI. We've taken steps to take. So there are a few hosts that were compromised and have evidence on them that they were running GitHub runners, which the attacker used to connect to an external GitHub repository and run workflows on them. So we've taken those out of Jenkins. So a few platforms are slightly down in capacity, but they were the ones that were remaining to be fixed. They had a bit more capacity than the others anyway, so we've left them to a little bit later. But yeah, Jenkins itself, there's nothing connected to it now that's been compromised. What we have done is, so when we looked at it, the attack vector that the researcher did, we actually found that it was the actual exploitation surface area was much bigger than the way they actually got in, and the time of use bug is really that for as long as I can remember, the Jenkins job just had like a few parameters, and one of the parameters was like the PR ID, and then it would always assume that the head of the PR branch was the thing that you wanted to test. And what we found was that you can push, anyone who's got access to the PR, so that's the PR author or collaborators, can push to the PR branch. So even though you start a PR on the node.js repository, the PR references, like the one on the screen there, that refs pull 57687 head, the PR author can always push to their own PR. So when we start a job, we are only passing the PR ID, and then as all of the sub jobs ran and then looked and said, all right, I need to check out that PR head ID, they would just blindly pull down whatever that reference referenced, even if that reference, was being updated or changed. So what we've got now is that I've added a new field into all of the jobs. So that's the test PR job, but also the node test commit job it calls, and then all of the node test commit, like node test commit dash Linux, node test commit Windows, node test commit OS X. All of those jobs now have extra parameters which you pass in the SHA, and that SHA, so whoever submits the job or the automation, when we fix the automation, needs to pass in the SHA that it believes the PR head is. And the reason to do that is, for example, we normally rely on the person submitting the job to say that yes, they've validated the PR is safe to run the CI with. But the gap is that there may be a change between the actual commit or PR contents that were reviewed and when the code is actually checked out. So this is now an additional check where the person submitting the job or the process submitting the job tells the job that it expects the reference that the head of the PR to be this specific SHA. And if when the job runs, or any of the job runs, finds that head does not match the commit SHA check, then it aborts the run. So it's a way of making sure that the PR hasn't been updated since the person or process submitted the job. And there's a number of ways that you can exploit this. So the attacker used the request CI workflow, but equally, because of the way the jobs run, if you were like constantly monitoring your PR and someone, for example, manually started Jenkins, as soon as they see the link to the CI posted back in the PR, they could push and update the PR. And because we run jobs where sort of node test pull request starts node test commit starts a whole bunch of other tests, so a whole bunch of other jobs. It could be a while for all of those jobs to check out code onto the machines. And it can be effective, for example, like if the CI is busy and you've got lots of other jobs running, you could have a delay of minutes or even in some worst cases hours between the job being requested and actually being run on the machines. So there is a real timing hole, which is a little bit hard to predict, but can be exploited. It's a little bit easier the way the researcher managed to get in, because we actually have a built-in delay with the request CI labeling and the way that was being picked up. But yeah, as was mentioned, that's not strictly necessary to trigger the exploit. So while they got in that way, it wasn't the only way you could get in and exploit this. So that's why it's taken a little bit of time to mainly to analyze the damage. One of the issues we had with this was it was reported, but we had to look at everything to find out like what was actually, which jobs were running affected code, and then which machines those jobs ran on, so that we could take them out. And then once we've done that, start figuring out, well, how are we actually going to stop this from happening in the future? And yeah, there's a number of things bandied around, but this seems to be the most safest way of like being sure that the code being checked out in the machines is the one that was intended to be tested on. Now we have, when I initially did this, I made every job submission required the additional SHA. That causes a few problems with some of the, so we've got a few jobs that run like every day. So there is a node test commit daily job, or is it node test? Can't remember the exact name. There is a job that runs daily, and it's the one that the CI reliability, no, is that true? No, CI reliability doesn't look at that. Sorry, ignore that, I'm mumbling. Yeah, but we had a few jobs that run daily. They weren't passing the SHA, and we're trying to work out how to do that, but I've actually relaxed the check now. So if the jobs are started and the organizations and repository is node.js/node, and the branch is not a PR branch. So if it's like main or like the staging branches, or there's like a V8 Canary, sorry, Canary base, I think there's like various branches in the repository that are not PR branches. Those should be safe, or at least we've given collaborators right access to the Node.js repository. So if a collaborator wants to, be malicious, then we've got bigger problems than the CI. But yeah, any PR, because we don't, we've deliberately for the moment not given Jenkins right access back to GitHub, or like even read access beyond the user sort of checkouts. So we're not running, for example, the GitHub command line tool in Jenkins. So it's not possible to abuse the GitHub API, at least through their client. We don't have any tokens or anything there. So at the moment, Jenkins doesn't actually have the ability to look at the PRs themselves, other than what's in like the Git repository. Anything else? Probably not mentioned. So we've always deliberately kept the test CI and the release infrastructure separate and isolated from each other. And one of the reasons for that is precisely this, in that while we hope we never get compromised, we try to limit the damage in the case of a compromise. So in this particular case, the only things that were compromised were the test machines, and we took them out mainly due to caution, because if you can run a GitHub runner on these machines, then anything as a limited user account, so the builds run as a user with restricted privileges anyway, but they can access the internet, they can install things into, write files into the local, into their own user directory, and run things from there. And that's all there because our tests kind of rely on that, being access. Some of the tests reach out to the internet. Some of the tests, execute child processes, as in other node processes, or even like some of the Unix commands to do things. So the machines have regular user access, and that's what was compromised in this case. So the release stuff wasn't at risk, and you couldn't get from the test machine to any of the other machines. But the actual cleanup for this it just took a long time, because we were trying to look at everything and make sure that we hadn't left any gaps, or other ways to get into the system. So yeah, I think that was everything.
Thank you very much, Richard. So we are going to reopen the CI soon, likely today, okay, with the check. There is going to be a significant change on our request. CI is going to be applied. The change is request CI label. Antoine, maybe you want to highlight what is the main difference?
So only PR that have been approved will work with the request CI label for the time being. And we have to find a way to make it convenient to run CI on an approved PR, but that's not something we have to build.
On that topic, I contacted GitHub support, asked for their help. They have absolutely nothing for that use case. The only thing that is available is building a massive data processing infrastructure, receive a dump of all the events that happens in the organization, and get us that information ourselves, if we want to do this kind of things, which is a lot of work, to be honest. So I don't expect, I think that the solution here is, so the change that Antoine has designed is it will run CI on the latest approved commit. Okay, so it will not, you cannot do, if you want, you need to start it yourself. Okay, I think we can probably relax this for collaborators. so that if you are a collaborator, you just keep for pushing your branch, you can probably start it. Because again, we have other problems if collaborators want to do nasty stuff, they can essentially push commits. So, but yeah, that is the current state of the problem. So hopefully we'll resume the project operation soon and start landing things again. Which I want to thank Richard and all the people that worked on managing this. This was not easy. I want also to thank Robin and all the people on the Linux Foundation that helped us in dealing with this thing. Okay. After this week, we're probably going to write a blog post to be published next week in which we describe what we said here. Given that most of this anyway is half public, please refrain from tweeting on mentioning it. But again, I think it was a good venue to talk about the problem and so on and so forth. So we'll probably do a call next week to start drafting that long blog post in which we describe all the things that happen. So yeah,
Is this being live streamed?
yes.
It's not live streamed on YouTube. But the talk is being recorded and people can just join this call. It's a public link.
Okay.
So,
But we know who's all on.
yes, we know
Right.
who's joining.
Yeah, might be want to chop the recording now, like stop it, start it again, so that it's not good.
Oh, yeah.
I think what we want to prevent is people who are not developers will see node security incident and think that end users were impacted.
Yes.
And so we are very explicit in that, in the blog. That's just sort of the holding pattern blog, not to create widespread panic.
The problem, part of the problem of managing this is this incident has been visible.
Mhm.
And somebody could have essentially sent a bad email to the register or some other, bad press that is out there, okay? We know a few of those nice companies that are publishing very nice blog posts on us. Everybody has their favorite. So we wanted to put something out ourselves so that at least we acknowledge this happened, so that it doesn't create panic.
Mhm.
Okay, and it doesn't create questions that when they are not. So we will publish a full report and so on and so forth. And this was hard for a lot of the TSC member, and especially for Richard that did the heavy lifting on the machines. So yeah, that was a lot. It was very stressful weekend for a lot of people. Okay, to be clear. So yeah, no, this is the gist. I hope everybody enjoyed the report, okay, or the situation. So somebody had a lot of questions on GitHub. I've seen a lot of people starting having questions, poking around. When will I get back request CI? Okay, this is the question that everybody will have in the coming weeks, probably. So we need to be careful in that, but I think we should. That would be probably the next thing that we need to do.
And if your project is using a label to start CI or stuff like that, maybe check for this kind of problem, because it's a pain when it happens.
And also unhappy with the researcher, but we don't want to communicate that. We don't want to antagonize researchers. Keep a professional.
We're unhappy. We're happy or unhappy with the research?
It's
Oh.
not best practice, probably. What do you?
Okay, yes. So it is
Sorry, is the part that we talked about, can we publish that or should we just cut those?
I would say should be cut, what I'm going to say.
Okay.
So this is probably the part that should be cut.
Okay.
All the rest can be public. This is the part where it can be cut. So we can discuss it after maybe. I will be very happily responding. If we want to stop recording for 5 seconds, I can probably give you the gist.
The pause record.
Let me, how to do that?
It doesn't.
That should be a push button.
I'm not pretty sure.
Screen
Sorry.
share.
Back.
Like, is that, sorry, can I talk again? Is
Get the stick. Oh, just one.
I won't mind that. Like, it seems like quite a long time to set up an environment to run potentially quite cheap CI checks. Like, is there any low-hanging fruit with like creating a more lightweight CI runner setup? Which will need something ready to go that maybe just use Docker or something. Anyone?
We have multiple platforms. Very shortly, we have multiple platforms, so Docker is not always an option.
And there's nothing equivalent for Windows and Mac.
I think so.
For Mac OS, Ryan from the foundation has converted us to ephemeral Mac OS runners, so the Mac OS stuff wasn't affected. It might be something we look at for, say, like the Linux on x64 or an ARM, which tends to be the ones in the cloud providers that some of have APIs, but obviously that's re-engineering work. So I think there is scope in the for further actions that could, make some of this some of it less risky, I guess, is that's the word. But yeah, we will always have platforms that are not that require a bit more setup.
Yeah, and is my understanding correct that we have a trade-off to make between caching and security? Because if we reuse the same machine, it's very fast to rebuild.
Yes. So for everyone complaining about build times and how long it takes to build Node, most of our test machines, actually no, all of our test machines use some form of like Ccache. Ccache is a way of caching compile artifacts. So when you use the compiler to build Node, we are using caching between builds, which is slightly discouraged from a sort of it is possible to affect subsequent builds through the cache, but we haven't really looked at that in great detail. But I mean, the trade-off there is, without the cache, on some platforms, the build takes like 5-6 hours, maybe 8 hours now, I think. The build times have got steadily worse with every V8 version that we've gone out with. So I think now if you don't have a cache on some of the 2 core machines, the builds are up at like 8 hours. And that was one of the things that Ryan was looking at with so the Mac OS stuff, we've just recently, end of last year, moved to ephemeral workers. And then Ryan was trying to set up a shared storage to connect to the ephemeral workers to store the Ccache. But that still isn't working yet. There are some permission problems reading. So I believe my understanding is the cache is being written but not being read properly. So that was resulting in slower macOS builds. I think Ryan has a way forward on that, and that might be getting fixed soonish. But there are issues with having sort of throwaway sort of agents. You can kind of see it in the GitHub workflows where I think Michael Zasso added Scache to the main build jobs, but without that, the builds were taking, I think, 2 hours or 3 hours in GitHub. And again, that was because before that, we didn't actually have caching between jobs. I think maybe one of the things I would add is a lot of the thing with the CI is it's evolved over time. And probably if you were to sit down and design, a CI for a for a large project, it might be slightly different from what we've got now. I will say that what we've got and has been evolved came from before before GitHub Actions even existed, and I think before even like things like Travis. We were running on Jenkins, I think from like at least the IOJS days. I wasn't around. Well, sorry, I was just about around then, but I wasn't in the build working group then. But yeah, we've been working with a Jenkins setup that dates from at least 2014. It has evolved, it has been updated slowly in that time. But it's the general design and things like, you know, only submitting the PR ID to the jobs, that dates all the way back to then. So yeah, you know, we have a CI. Occasionally you get lots of people coming up with good ideas of what we can do to change the CI. And the problem with all of that is, how do you do that? Who has the time to do that? And how can it be done in a way that's not going to be disruptive to, you know, if someone says, oh, you know, we'd like to make a refactoring of the Jenkins CI, but we'll need to take it out of action for like 3 or 4 weeks, then you have to balance that between, you know, what's the cost of the project of this? I mean, in this case, it's been what, a week and a half without the CI running, and you know, basically most, you know, a large amount of regular work has stopped. So you could still land PRs that were like documentation only, because documentation only PRs don't require a Jenkins CI, but everything else is kind of paused. And yeah, that's always the 2 main problems we've got in the project are time, and I don't think that's that's just, you know, that's not just a build problem, that's a project problem in general. It's like, who has the time to do whatever needs to be done for the project? And the other one is, can you do it in a way that's not going to disrupt other people? So, you know, we've got 100 odd collaborators, I think, at the last sort of count, and you know, they could all be affected by taking bits of the CI out of commission, or, you know, taking the whole CI out of commission. It's generally why we try to avoid things like lockdowns for anything other than critical stuff, so security releases, and, you know, in this case, the response to an actual incident.
Anything else about the CI? Or do we want to, we still have, I think half an hour left. Or the, have 15 minutes left, about the CI. So, might as well go through the flakes, I guess, if, you were no problem with it.
Sure.
So this is the latest report of the CI, but if you complete, because we have paused the CI for quite some time, so it's not really showing up what would happen if the CI is actually under load. Has not been under load for a week. This is the reliability report, the node.js reliability report is where we have this workload. Oh, Richard has extended, right? Richard, you're trying to say something?
Richard, if you're speaking, you're muted.
Sorry. Yeah, yeah, the CI's been locked down, but I think this automation looks at the most recent 100 jobs. So it will still show some of the stuff that was occurring before we locked the CI down, because I only ran a few test jobs through while it was locked down to test the, you know, the changes.
Yes, so this contains a workflow that runs the command line tool, like part of NCUCI, which just does it's running a bash script, but that script basically just runs NCUCI for the latest 100 jobs in the Jenkins CI, and try to find patterns of failures, basically a bunch of regular expressions, essentially. So for example, it generates a report like this. Every day it runs the command line tool over the entire CI, and then opens an issue with this summary. because GitHub has a limit on the data length of the issue body. So we move that actual report into a file in the repository. So you need to, like every day there's a new issue, which links to a file, which will kind of summarize what's been failing the CI in the past 100 runs. So this is a very primitive parsing. I think I implemented this in 2018, like 7 years ago. Haven't been really updated a lot ever since. So it's a very primitive form of parsing all the console logs of past Jenkins CI runs. And then it will just show what's the latest status of the CI, which you can see only 3% is green. I think this has been measurable for 7 years at least. Basically the point where like the tool was written, and ever since we have some automation, I think Richard added that to actually do it, to actually run it every day. So it has been like this for 7 years. Because I guess if you are a collaborator, you probably is well aware that that the RCI is incredibly flaky, and this is like a reflection of that. So this workflow is like one of the ways that we use to try to find out what is actually flaking the CI, so that if anyone has time to actually look into it, you know where to look, instead of like, I don't know, looking at the past reports manually. So for example, usually this can be ignored. It's usually intermittent, like random failures. Usually you can ignore this because these usually do not come up as problematic for every say run. It's just like some random failures. Git failure tend to be fairly rare as well, unless there's actually something wrong with that thing. So if you're actually trying to take a stab at helping out with CI, and you see Jenkins failure, Git failure, and most of the time build failure, and you're not a build group member, a working group member, usually what you need to do to fix this is asking someone in the node build Slack channel or opening an issue in the node build CI, so that they will be able to actually fix them, because usually that requires Jenkins admin access or logging into the machines. So if you're not a build group member, you will not be able to fix them usually yourself. But you can sometimes provide advices if you are familiar with the specific platform. So these are usually build failures. And this one is, well, this is a JSON parse failure. Something is wrong with the Jenkins API. So usually things above CC test failure and JS test failures are usually like the build group territory. And then below that is usually what people can help the most is trying to fix flags. Like this one, the JS test failure. This has failed 14 per requests in the past 100 CI runs, which means this is pretty bad. If it has failed this many per requests, which also means it's likely a flake, because it affects so many related per requests. So it must be a problem already existing in the CI. And in the report, we have which platforms, the platforms where these appears. I think in this case, this is likely a dynamic link build in the shared container builds. And then, for example, for the first one, if you click the link, it doesn't go to the pull request, goes to the Jenkins build for the pull request. Although you can, you can also click because you can go to the request from the Jenkins CI either way. So this links to that one. Jacob has his hand.
So it tracks how many times it has failed a pull request. Does it track retries? Because like sometimes maybe it's just something that people break a lot.
The number is based on pull requests, pull request IDs.
Mhm.
So just that, the number is number of pull requests that it fails.
Okay, would it be, I think, more useful, would it be possible to check if it subsequently passes on a retry?
It doesn't, because it's for checking out what's flaking the CI. So even if you succeed in the later on, it doesn't change the fact that these pull requests, like this has failed these many pull requests.
So
But
even if it goes fail, 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 pass, you still see the failures when making the report.
yes,
Yeah, but I'm wondering, like, if there's a test that people are legitimately breaking a lot, that could give you.
that will only fail
false
that
alarms.
one pull request, it will not show up in the report. If it doesn't fail other pull requests, then it does not show up in the report. There is a threshold.
Oh, if it does other ones.
It needs to fail
Okay.
at least two, I think at least two pull requests, independent pull requests.
Okay,
If it's just filling this pull request, well, it's your problem.
Yeah.
If it's filling 14 pull requests, then it can be,
yes,
Um,
okay, got it.
it's something in the main branch or something in the CI.
Okay, cool, thanks.
So it's based on how many pull requests this has failed. And then, in the Jenkins job that references, you'll have whatever that tells you, what is causing well, this one isn't giving much because it's a timeout on this test. But that's like all you have, unless you do something in the test to actually have reproduce. But this is what we can get out of the CI about the flake. And sometimes this will be useful. The first CI where this shows up. If this is new, then you can pinpoint which commits start to introduce this, because you can, for example, check out the commit that it's rebasing onto. And sometimes, I think there were several times when I found out there was like a commit on the main branch introduced the flake, then you can find out which commit that actually is. Like for example, this one, you go to test commit and you see where it is rebased onto. Or more specific, like let's see which commit is rebasing onto, then sometimes that's helpful. Sometimes it's not a specific commit, or this has been in the main branch for a very long time, not really related to any recent commit, then you need to do something else, but sometimes this can be useful. To the report. And the last one, because sometimes this already goes away, so you can tell that it's already gone. Sometimes they're random, most of the time they're not. And this just gives you whatever in the CI that's related to this release, which in this case is a much timeout. That's one of the trickiest ones. Or for example, this one, which seems to be looks also pretty random, just Linux and R, Linux on R probably. Also timeout. These all look like related to that dialog issue. And this one is likely also a timeout. Because the thing has a timeout. But yeah, that's basically it. If you are like me, sometimes you cannot stand the CI anymore. You can just go through this report, the latest report, and see what's failing the CI. Or even if sometimes you're just not sure whether you're being flaked, and it's not really something related to your purpose, you can check out the reports and see if it's already in the reports. And if it's failing other pull requests, then it's likely not your pull request causing this, but you still need to get a serum, but at least you're very sure that it's not yours. And I would say this testing actually doesn't look that bad because it's not a lot different, a lot of different flakes. Flaking the CI is Just one that's very problematic. And another one that's very problematic, and a bunch of other ones which might or might not be actual flakes or might be CI hiccups. So, that's the overview of the reliability thing. Look has it.
Oh, I was just wondering, what's a typical time frame for last 100 jobs?
I would say a few weeks. It also really depends on how busy this is. Like this week is like an exception because we paused the CI for a week.
Okay.
But I can't really remember, but maybe like 3 weeks or so. Usually it's around that. But we also keep all the past reports. So I think all the way to like 2020 or something. So these are the ones that we moved to a file ever since we noticed the issue body link limit, but we have a lot more in the issues. It goes all the way back to 2020 or even more because there's like next. It goes all the way to this one. So you have a lot of past reports. So you can use both this to search or like the repository search. If you want to find out the history of a certain flake, because some of them can be very old. There was like one that I only marked flaky after it has been flaking the CI for a year. It's actually not rare to have a flake that has been flaking the CI for a year without being taken care of. So yes, it is more love. So that's the overview. And I guess we are reaching the time to end this session about CI. Next one would be lightning talks, but we have no, I don't think we have any submissions. We don't have any submission. But if anyone wants to talk about what they've been recently working on, I think Chenjong, you proposed the session. Do you have any things you want to talk about that you've been working on?
Well, it's not strictly my work. It was raised by Guy Bedford. That he said, can we have a short talk about WebAssembly? I think I will share the issue.
Alex, do you? Yeah,
Yeah, it was for the previous thing, sorry.
Oh.
You have to do a running tour. I mean, given that we don't have any lights, I was just gonna say, like, did we do any statistical analysis of like which tests are failing most? Because it feels like if we could prioritize the flaky tests by which one cause the most.
Yes, there's the number, like 14.
That's just like a number of different PRs. Is that like the best way to do it? Like,
yes, because that thing has been there for the longest time, and nobody is adding more statistical analysis.
Right.
If anybody wants to do more sophisticated thing, add more sophisticated counting, they can set up a request to upgrade us.
I think one thing that I've done at my company is when new tests are introduced, you can kind of like run them 100 times rather than just run them once and then accept them. And you can see if it passes 100 times out of 100, it's probably okay.
Oh, we do have that. We do have the stress test job.
Okay.
There is like a command line argument we can pass to the Python test runner, which can run the test like 1,000 times.
Okay. Thanks.
And see if it reproduces under pressure. But that's usually used to after you like when you want to isolate a flake. You already know this is a flake, and you want to know whether it reproduces or whether when you make some changes to the test, it still reproduces. That's usually when it's used, but we do have that.
Right.
It's just not used as part of the flake detection because the flake detection is based on how many probabilities has failed.
Okay, it's good enough.
Joy, are you sharing the screen?
Right? Oh, that stop share.
I'm not necessarily like, something that I heard was when adding a new test, let's make sure it's not flaky. Okay, which is, it's a lot of work probably, but
Yeah, I guess maybe other people like Richard from build working group would have more idea, but my impression is that it'll take a lot of resources to run, like really stress the test. Also, you need to know which platform you are stressing this. Instead of stressing it on all platforms, that can.
stressing on our platform is. Like, we had some tests that were essentially flaky mostly everywhere. Essentially, like if the test is flaky, there are some tests that are flaky only on one platform because it's always condition specific to that platform. There's nothing to do there. But I don't know, I was mostly thinking, maybe can we do with GitHub Actions something relatively simple? There is a new file being added in test, we run it, I don't know, 100 times or something, 1,000 times in GitHub Actions, something that does not overstress our CI, but it's try to avoid try to make sure we don't do that. Okay, we don't make situation worse.
Yeah, like the question I would have though is, are flakes more coming from new tests being added or existing tests? The logic under it changing.
Okay.
Like someone makes a new pull request and then this other test that they didn't realize was related and suddenly starts failing. I think that's probably actually more the case.
It's never going to be perfect, is it? You just got to try and focus on the areas that are most likely to.
I would say in my experience, there's no, well, there are certain components I can think of that are rather problematic, like inspectors and watch. Somehow they're just extra flaky compared to others. Well, watch is already, not already very reliable on all platforms because it has events, but inspector tend to be fairly flaky as well. So maybe for specific features that we know are kind of prone to fakes, we can run more stresses on it. But
what about, has anyone ever considered just like setting a fixed budget for like compute, or I don't know how you measure it, dollars or something else, but constantly randomly rerunning tests on random platforms and random numbers of time and just trying to discover the correlations between failures, and then kind of let you hone in on problematic patterns?
we do have daily CI on the main branch. And the thing with the daily CI, well, this problem with the CI in general is that nobody is paying attention to it. Nobody has time to look after it. So you can have the daily main branch CI failing for several months without anyone taking care of it.
Okay.
That's the main problem. I was just trying to show the daily CI. I'm very sure it's still.
Not very
Uh,
sure your screen's not showing.
yes, I
Sorry.
can. Well, it's been red for I don't know what. It's been red, fully red. I'm sharing. I'm just going to share this. I see. You see, this has been red for where is the good?
As long as there is history.
Yes.
Since records began.
It's just red. Red. And nobody takes care of
But
it.
is it kind of like the boy who cries wolf? Because if it's always red, like you can't really tell when it's getting better and when it's getting worse. Like.
I think there were still occasional green, but it hasn't. Richard has his hand up.
Yeah, it's been red for a long time. The main reason it's been red for a long time is the pointer compression build. So if someone has time to fix the pointer compression build, or we actually just make a decision to eject it, you'll need to find a job is that the latest one or the one just before the latest one?
Like the
Sorry,
latest?
that one, try that one, yeah. So for example, in this one, pointer compression, IBMI, I've actually, the IBM people know about that and are looking at that. The workers one, so it's, does fail from time to time. And again, it's just, like I said, people looking at, I don't know if that's a setup problem or a, so the internet tests tend to only be run on the dailies, because they rely on things on the internet. So I guess it's questionable as to how reliable those are going to be, but things like the pointer compression build is not building, I think. That is my recollection. Yeah, I've mentioned it before when people talk about the state of pointer compression, and I just point out, well, you know, pointer compression builds have been broken for a long time and no one's stepped up to fix them. So, you know, if the ask is that we add pointer compression into into a more supported sort of format, it's like, well, no one's looking at it now. Who's going to look at it in the future?
Have the pointer compression build be cut if it's failing always? As in, does it?
I would be up for that, but it was added because other collaborators wanted it. So again, it's this kind of, I think if it was the only thing, I probably would suggest it. But there are, you know, there are other platforms at the moment that are flaking, and yeah, it's like Joy said, it's, you know, we've been running this for years and years and years and years, and we've had a few collaborators that occasionally pay attention to this and raise things, and then other periods like now where they tend not to get looked at, where people are looking at it, they're not really raising any of the issues to try and get them fixed. But anything that's flaking in like regular PR workflows will probably flake in the daily builds as well. So
Yes, it just needs more love.
that particular one, the one you're looking at, that's already marked flaky. So at the top there where it says flaky, that means someone's actually marked it flaky. So although it's failed, it wouldn't cause the build itself to fail. So Windows has failed for some other reason other than that one.
That's marked flaky. This one is the actual favorite. It's the timeout.
Yeah, right. Yeah, so that's the reason that the Windows build failed.
Yes. Yes, Chenjong is ready to share about that.
Sure. Would you?
So that I can share. Well, yeah, this is a request from Guy Bedford that is going to unflag WebAssembly module support in the ECMAScript modules in Node.js, so that we can directly import WebAssembly modules without any flag and without any boilerplate code to set it up. We can directly import a WebAssembly module. And the issue is that this podcast was originally set up for unflagging it in Node.js 24, but unfortunately it takes a little bit more time to coordinate with process. So yeah, we missed the deadline to get it into version 24 as it was already cut off. And Marco marked this request as server major. So that basically means that this should only be unflagged in version 25. But this brings difficulties in build tools for WebAssembly, like mscripten, which will delay their adoptions of WebAssembly modules. So what we were hoping for is that can we remove the server major label on this and make it available on version 24. And later on, we can backport it to previous LTS versions so that build tools can adopt this change in WebAssembly modules.
Does this have to be server major?
Well, we talked about several precedents like require ASM or TypeScript support in Node.js. which were not single major in the modules space. So we were thinking that maybe this can also be as a single minor instead of single major. Taking the precedent of these module changes previously.
What was the reason for suggesting it be major in the first place? Because like normally we don't call something major until someone specific.
Yeah, I remember why.
And the whole point of making it experimental was.
Please,
Thank you. So,
please speak up, please.
like, can I speak? Okay, so the reason why I labeled it sample measure, because at the time, node 24 was not out, and it relied on something that was on node 24. So it's fine to go as sample minor in node 24.
Oh, that would be great.
Because that was sample major change from when we were in 22.
But that's
Before we were in 24. So it's fine to land on sample minor.
yeah, the right label should be don't land on 20, whatever.
Yeah, because it was relying on a sample major change, which is the V8 update.
Oh, right. I think technically the right label will be don't land.
Okay, so yeah, it's fine.
Yeah, probably. When this was open, wasn't there already the label for 24? For 20, yeah, well, the label for 23, so yes, it's good. Yeah.
Okay, yeah, we can.
Yeah, but anyway, I think the issue is that it takes a little bit more time than we expected to coordinate with browsers, so it means the 24 deadline, but if we can land it in a single manner, I think it's pretty promising.
Yeah, that's on the target with the online on 23, 22, 20.
Well, if this does not cause any breaking change, I think it will be promising to backport it because build tools like scripting can migrate to the new behavior more easily.
But it relies on V8 being on version that is not on.
This particular feature should not rely on V8 behavior because it's like a module loader that loads a WebAssembly module.
I think Guy mentioned that it relied on source phase imports for WebAssembly.
That's the WebAssembly WASM-CG specification. It's not the V8 change.
Okay.
Yeah. It's WASM-CG. This proposal in WASM-CG is phase 3. So what the guy was mentioning is that this proposal is in this standard process, but we would like to flag the feature, but with a option to disable it like -- no experimental WASM in modules.
Just to check, that sounds a bit like experimental WASM support would be on by default, and you would have to use no experimental WASM support to disable it.
Yeah, it's just that we are going to enable it by default, but you can disable it with an option.
I think it has precedent for experimental things being on by default.
Yeah, yes.
Yeah.
Yeah.
Oh, I think. Wait. The reason I asked to wait for merging this because there is some open discussion about what to do when like WASM exports globals. Like that's the only big open discussion left. Maybe like if anybody has opinions, then like go check in the pull requests and say, oh, I think it should behave like this or like that. Because like that would be helpful to move the proposal, like to move the discussion forward.
Yeah, there's another pull request for WebAssembly global support, but yeah, this is another work.
Yeah, this pull request is the part of the proposal that's still like being discussed. And I believe guys want to wait for this discussion to settle before like applying in the future.
Yeah, I think that's the lightning talk.
Thank you. I do have something that I've been working on that I think it's worth share if nobody else is trying to give a thought. So I waiting the screen. I actually have okay.
One, two.
Uh, this is something that I've been trying to work on by, which you might have already noticed in the repository that we have a few wrappers that used to be base objects and now they are CVGC, like managed by OilPan or CVGC. Like technically that's the namespace in VA, which is a Silver's garbage collection library that VA provides that allows you to allocate civil objects on the heap that VA manages. So that you can use the primitives provided by VA to set up references between whatever they have in C++ and whatever they have in JavaScript. So that VA garbage collector can make sure that it sees all the links and not have some weird memory leak or use after free issues. So I've been trying to kind of develop some like common helpers for us to gradually migrate certain base objects to be managed by CVGC. Because we made a lot of assumptions in our wrappers about how their lifetime should be managed, which is tied to the lifetime of environment. So you kind of need some kind of like abstraction layer to make sure it ties into our existing expectations, as well as making sure that at the source level, you don't need to rewrite a lot of code. For example, when you have a base object, when you try to get to the environment, you just does the env method to get the environment. You kind of need to implement a shin for all those methods if you don't want to like rewrite all the code that use these helpers. So this is basically a shin. And we currently have two classes that are more basic and are more like prone to memory issues already migrated. Those are contextify script, which is the thing that underpins vn.script. This used to cause a lot of memory leaks and use after free issues that once blocked a lot of people from upgrading from Node 16. And so we recently did a bit of migration of this after we fixed the links and memory issues, but this hopefully would make the management more straightforward because we can use the VA primitives now to manage the links. So this one has already been migrated. This basically just used to be like inheriting from base objects. Now inherent from CVGC mixing. This is our helper, and you need to do a bit of a macro thing to because of the way that VA requires it to be templated. So you need to use this macro to construct a base class. And then you use a bunch of macros, which are not so different from existing like base object or memory retaining macros. So this is basically how it went. I think when I did this one, it's just like changing a few macros that you use. And then all the global references are now trace references because this is something that VA will be able to track the links with. Whereas VA global is, as far as VA sees it, is just like some global references coming out of nowhere. Whereas if you use trace references, you can, there's a trace method where you can set up the link for VA to actually do some marking on it. So we currently already have two classes that used to be very prone to memory issues already migrated: contextify script and contextify context. And context is just like a wrapper around VA context. And I have this giant blob of ASCII graph about how it works. This is contextify script. Contextify. Right, this one is also migrated. And these are very basic classes. They don't have external memories, which is why it's easy to migrate them. The thing that they really need to keep track of are just some VA thing. This thing, we do not track them in heap snapshots anyway. So this is fine to, it's fine to not track this again in the CPGC migrated version. But as we kind of expand the amount of base objects that we need to migrate over, we need to have primitives to track external memory, because otherwise the information about the external memory will be lost in the heap snapshot, which is like a kind of a regression, not critical because it's only used for memory diagnostics, but you do not want, like, for example, you have a OpenSSL wrapper. It has like a gigabytes of vector, like growing vector of memory, and you do not see it in the heap snapshot when it starts, like, you want that to still show up. So so that's the thing that I've been recently working on, is to try to invent a way to track this external memory. The first attempt was to upstring a VA API. Well, technically it's a CPGC API, which is not strictly VA. And they're like, they're not really looking into accepting that because it's not going to be useful for Blink. So the other route is to just add some internal helpers to make it possible to track this in a, basically how we used to track base objects. And when we generate a heap snapshot, we just go through the list of CPGC wrappers and annotate all the nodes in the heap snapshots to show the external memory. And that's something that I recently been working on. Let me show the. So there is a work in progress pull request, which I have stalled a while because the CI was not working. But I just updated, I think I updated this probably. This is the some additions to the existing wrapper to allow the heap snapshot integration to work with the new CPGC
Not sure.
helper. Oh, yeah,
That's the screen.
I can also just show from here. Sorry, I wasn't sharing the pull request because it's just sharing VS Code, but this is where the additions are. Let's see. Yeah. There is now like a list in brown, I guess, that just tracks all the well, in the pull request, this is in a pull request, it's not merged yet because CI problems. So the idea is to have a list that's program that tracks all the CPG developers, which is not too different from how the base objects are tracked. And then when a heap snapshot is taken, we iterate through the list to annotate all the VA or like all the JavaScript nodes, and should kind of add extra nodes to them to show how much external memory that you're taking from this CPG driver. So I can show this. So for example, this is a hash object created by node hash, crypto.create hash. So there will be, for example, if you create a hash object with crypto create hash, there will be an hash object, and you'll be able to show as before the message digest context. This is how big it is, and this is the message digest that can be cached. In this case, it's not big, but if you have a variable length output, it can get huge. It can be as big as you want. So this is what the current integration will look like. I was doing this one as a prototype integration of the external memory thing. And the integration just, the migration is pretty simple once we're on top of the helper updates, which basically comes down to like you change base object. You change the constructor a bit to stop doing base object, and don't use make weak because we don't need that anymore. This is already traced from the CBGC heap anyway. You use this thing in the constructor to set up everything. And then in the trace method, which is required by CBGC, you use a trace method that's provided by the helper. And there we have the memory info method override that we used to need to do. This is basically the same. I was just trying to add more names to it, but this could have been the same. I just trying to make it more readable. And basically you just keep the original thing. And when you allocate it, you use this thing instead of just new. Because it cannot be allocated with new. It has to be allocated with the CBGC this method with the allocation handle from a isolate. And then you change the class declaration a bit, and it's done. So it will just pretty much it doesn't really require a lot of changes. But you will make sure that hash is allocated with CBGC, and but this number is a bit old, but it actually has some weird speed up in the actual hashing performance, because when you do a micro benchmark, a lot of the time is spent on garbage collection, and this would improve the garbage collection throughput a bit because VA sees everything. So it actually has a bit of funny improvement in the micro benchmarks. So that's something I've been doing, and I hope that I can merge the helper request when the CI comes back. So yeah, that's it. So we are having the lunch break.
Really, this a new way of managing tracking objects in C++ land provide better improve generic garbage collection times.
I think it really depends on the usage pattern of the object. But as far as I can tell, there isn't really any regression I can see from at least micro benchmarks. And in theory, it's going to improve performance because VA now can see everything.
Okay. So So in the previous way in which we were handling this, we were creating a lot of persistent handles,
Yes,
which indeed is less, right?
yes, these are trace handles.
Yes, okay, so, okay, yeah, makes really, makes a lot of sense. Will it be possible to use this kind of system also for, I don't know, JS stream and those kind of, low level, the stuff that binds to libuv?
I think that would be possible, but because the lifetime is tied to some libuv handle, it needs some more careful optimization. I haven't really looked into that yet. Because they're, I guess, a bit more complex, but I think it should be possible. Just need to figure out how first.
Perfect, thank you very much.
Yes, we are. Stopping the morning session. Go have a lunch.
Yeah, I've just been informed the food is ready and set up downstairs for us in the same place that breakfast was. So.
The remote participants were stopping this until 1.5 hours later.
Yeah, if folks want to leave stuff in here, that's totally fine.